In the previous class, I have explained isomers of butane, isomers of pentane. Now we want to consider isomer of hexane. Hexane is how many carbon? Hexane is 6 carbon. We want to consider how we can draw hexane in different ways. How we can draw it in different ways, and it will keep giving us different structures. And then since we're having different structures, we are going to be having different names. The first structure you are seeing up here is hexane, and the total number of carbon there is 6. The total number of carbon here is 6, if you count very well. So total number of carbon here is 6. Now we want to draw this structure in different ways. Let's check the first structure here. Look at this first structure. Can you name it? Can you give this one name? And what is the name? If you are to name this one, which name will you give to it? The first thing you need to consider there is the first thing we need to consider is carbon with the highest count, which is our parent carbon. We need to determine our parent carbon first. If you are counting straight from your left, this is 1, this is 2, this is 3, this is 4, and then this is 5. This is our fifth carbon. Now, if you count from your right, you are going to have 1 here, and then the last carbon here will equally be 5. Counting from left to right, it is 5 carbon. Counting from right to left, it is 5 carbon. So we know now that our longest carbon is 5. Even if you are to, let's count from this edge, which is 1. When we got here, it is 4. So if we should go up, our number of carbon will still be 5. So regardless of how we are counting, we are going to have 5 carbons. And 5 carbons is regarded as what? So that highest number of carbon is 5, and since it is 5, our highest carbon is called pentane. Our highest carbon there is called pentane. Our highest number of carbon now is now pentane. Then we need to determine the attachment. When we are counting straight, like this, there's one we did not count up. We didn't count this one up when we are counting straight, which means that the one up here is our attachment. This one up here is our attachment. And counting from our left, this attachment falls on carbon number 2. This attachment falls on carbon number 2, which means that we are going to ascribe number to this attachment. And the number we are ascribing to it is 2. And the name of the attachment is methyl. Therefore, the name of this compound is 2-methyl-pentane. The name of this compound is 2-methyl-pentane. Remember how we arrived at the name. And this compound is an isomer of hexane because the total number of carbon in this structure is 6. Let's check another compound that is an isomer of hexane. Look at this structure as well. Look at this structure. If you count the total number of carbon here, it must give us 6. I have drawn this one we call this one condensed formula. This is a condensed formula. Are you following? This is a condensed formula. We have CH3 here. Remember, I have told you that if CH3 is at the edge, you don't call it an attachment. You count it as a parent because this one is at the edge. This is one CH3. This is another CH3. All these ones are at the edge, so we don't count them as attachment. It is only those ones that are in between and they are not counted as a parent carbon that we regarded as an attachment. So in this compound now, remember how we name. We are firstly going to consider the carbon with the highest number. That is the first thing we are going to do now. Counting from the left, this is the first carbon, carbon 1. And then we have the second carbon here, carbon number 2. We have the carbon number 3 here. We have the carbon number 4 here. Now, is there any other way we can get number of carbon that is greater than 4? Is there any other way we can get number of carbon greater than 4? I don't think so. So if you count very well now, if you count like this is 1, 2, 3, 4. This is also 4. And if you are counting up, 1, 2, 3, 4. So this is also 4. It means that the longest carbon here which we regard to as our parent carbon, will be 4. So let's pick the straight one and write butane down, because butane is the 4 carbon. Butane contains 4 carbon. So let's put our parent name down, which is butane. Since we know that our longest carbon is butane, the next thing we need to do now is to determine where we have our attachment, the position of our attachment. You see this like this. This is 4 now. Our attachment, this is one attachment up, and this is another attachment down. So the attachment up and down, we need to name them, and you know that we need to give them the lowest number. If you are counting from your left, all these attachments falls on carbon number 2, and if you are counting from your right, it falls on carbon number 3. So we are picking the one from the left now, which is number 2, and that means that we have 2 methyl now, one up, one down, and they are both on carbon number 2. So 2 for the first one, comma 2 for the second one, and then the total number of methyl that we have there is di. So we are now going to have 2,2-dimethyl butane. The correct name for this compound is 2,2-dimethyl butane, which is this place. That's what we have here right now, according to how we name it. And this compound is an isomer of hexane, because the total number of carbon here is 6. Let's check another isomer of hexane. I have given you 2 isomers of hexane now. Remember, one is 2-methyl pentane. This one is 2,2-dimethyl butane. Let's check another isomer of hexane. So how many carbon is our highest number? Remember, this is our hexane that we are talking about, and this is another structure we want to. This is another structure that hexane can form. Our highest number, starting from carbon 1 from left, you can have it like this, a straight chain like this. That will give us 4. Regardless of how you are counting, it will give us 4. Even if you count like this, 1, 2, 3, 4. So this one will also give us 4. Since our highest number of counting is 4, the parent name will be butane. So let's write butane down now. Our longest carbon is 4, and that is why we have butane as the parent name. Now it is the time to name attachment. So if we start counting from here, our first attachment is on carbon number 2. That's our first attachment. If you start counting from the left, and then that is 2, then another attachment is on carbon number 3. So we have 2 attachments, one on carbon number 2 and the other one on carbon number 3. I made this one. So this is one here on carbon number 2. This is another one here on carbon number 3. Even if we start counting from our right, we have one attachment at carbon number 2. We have one attachment on carbon number 2 and the other one on carbon number 3. In that case, we have 2 methyl, one on carbon number 2, one on carbon number 3, and we just have to give it that name the way we see it. 2,3-dimethyl, then our parent name is butane. That is the name for this structure, 2,3-dimethyl butane. And this is another isomer of hexane, because the total number of carbon here in all is 6. And if you get the total number of hydrogen compared to the parent one, which is this, you will see that it is the same. Now let's write the name of this compound down. Now the correct name for this structure is 2,3-dimethyl butane, and that is where we are going to stop the naming of isomerism or isomers of organic compounds. In the next episode, we are going to consider each family one after the other. Family of alkane, family of alkene, family of alkyne. Make sure you continue this structural formula from heptane. We are now done with hexane. See you in the next class.